Welcome back. So in this session, we are going to solve a problem on how to determine coefficient of friction. So the question reads, a particle of mass 2 kilograms is sliding down a rough slope that is inclined at 30 degrees to the horizontal. Now, when we are told that we have a rough slope, then that will tell you that frictional force matters. So given the acceleration of the particle is 1 meter per square second, find the coefficient of friction between the particle and the slope. So when we say the slope is rough, then it means that friction force must be considered. When you say smooth slope, then we ignore the effect of frictional force. So the first thing, let's draw the inclined plane, which makes an angle of 30 degrees with the horizontal. So solution. Simply the horizontal surface. Then this is the theta, which is 30 degrees. So this is the rough inclined plane. So next, let this be the point where we have the particle. And we can draw so this is a particle, then we draw the normal reaction, which is perpendicular to the surface. Remember, this making 90 degrees to the surface. And then this is how we draw the weight, mass times gravitational acceleration. So this is the particle. So this angle here is usually the same as the angle here. So this is still 30 degrees. Once we have drawn this, then resolve the forces on this diagram. So just join this to form a right angle triangle. And then this magnitude here will be W sine of theta. Magnitude of the force here will be W cosine of theta. And direction of motion on this triangle is that this, we are moving this direction, and then we are moving this direction. So we have this kind of motion where this is the weight. So this 90 degrees. So this is the W. And this is what you're calling W sine theta. This is what you're calling W cos theta. And theta is this angle here. And theta is the same as this value, 30 degrees. This is the motion direction. So resolving horizontal forces. So horizontal forces, X components. So remember, net force is given by mass times acceleration. So horizontal will be Fx equals to mx, and then Fx, this is the only horizontal force. So W sine of 30 degrees is equals to m times ax. But now that's not the only force because we've been told that we have a rough surface. So this is not true. That's not the only horizontal component. So we need to illustrate or show that because this object is going down, then we'll have a frictional force which opposes the motion. So taking this to be the positive direction, then you'll have W sine of theta minus frictional force should give us MAX. And we've been told that the acceleration is 1. So this is the same as saying mg sine theta minus mu r. So this is how we get the friction. Is given by m times 1, just m. So mu r is the same as mg sine theta and then minus m. So it tells us that mu is given by r, not really. Divide the right hand side by r. So mu is the same as mg sine theta minus m divided by r. So let's call this one equation 1. Y component or components. So F net is MA. Those forces which are acting vertically, we have R and this W cos theta. So taking the upward force to be positive, then W cos theta will be negative because this is acting downwards. So R minus W cos of theta is equals to 0 because AY is equals to 0, i.e. no vertical motion. So R will be the same as W cos of theta, which is the same as mg cosine of theta. So call this one equation 2. So replacing 2 in 1, we get that mu is mg sine theta minus m divided by mg cosine of theta. But remember, theta is 30 degrees, g is 9.8, and m, the mass of this object or this particle, is given as 2 kilograms. So m is 2 kilograms. This is meter per square seconds. So this means that mu is 2 times 9.8 times sine of 30 degrees minus 2 divided by 2 times 9.8 times cosine of 30 degrees. So we'll have 2 by 9.8 by sine of 30 minus 2. That gives us 7.8 over 2 times 9.8 times cosine of 30 degrees gives 49.3 over 2 over 5. This is 5. So that means mu will be 7.8 divide answer, which will be 13.3 divided by 49. So decimal to be 0.4 5 9 5 2 3 6 8 3 6. Remember, mu of the coefficient of friction has no units, so that means mu is roughly 0. That implies that mu is roughly 0.4595. 4 significant figures. So that is what we get. Thank you.